Hi, so this is how we are going to solve number 72. We have our two equations, vy squared equals vy initial squared plus 2ay times the change in y, and Newton's second law, change in the forces in the y direction will equal mass times acceleration in the y direction. Notice that we're using the y subscript here because this is only occurring in the y direction. The picture is just throwing it up, so we don't need to worry about the x direction. We have two equations and we have two unknowns, which is nice because then we can solve it. Our two unknowns are acceleration in the y direction, and we're going to need that to solve for the force applied in the y direction, which is the same as the force applied by the pitcher to get the ball at that upward speed. First, we need to isolate a in the y direction. In this first equation here, we need to move stuff around. So it says a in the acceleration in the y direction equals. Then we're going to substitute that rearranged equation that we did into Newton's second law. Finally, we're just going to plug in our known values, the values that we were given in the problem, and solve for the force applied in the y direction. First step, we're isolating a in the y direction. So we have our vy squared equals vy initial squared plus 2ay times change in y. We can rearrange this, and we should get vy squared minus vy initial squared over 2 times the change in y, and that should equal acceleration in the y direction. Okay, second, we're going to substitute this into Newton's second law. Remember that this symbol means the change in. So instead of just having the force applied, we need to include the force applied by the pitcher on the ball and also the force exerted by the ball itself. So that's why we are going to have subtract mg, the mass being of the ball, and g, acceleration due to gravity. So as you can see here, we just replaced a with that equation that we rearranged. But now we have the force applied by the pitcher minus the force applied by the ball. So we need to get rid of this bit to find out force applied by the pitcher. So we can add this. We should get the force applied by the pitcher equals m times vy squared minus vy initial squared over 2 times the change in y, plus that mg, plus that force exerted by the ball. Okay, third step, we're going to plug in our known values. We have this nice equation here, fy equals m times vy squared minus vy initial squared over 2 times the change in y plus the mg. We have our known values, the mass, the velocity, the initial velocity, which we're going to assume is 0, our change in y, 1.5 meters, our mass again, and 9.8 meters per second squared, which is acceleration due to gravity, this g here. You plug that into your calculator, you should get 21.47 newtons, but because of sig figs and the values you've been given, we're going to round that up to 21.5 newtons. So the pitcher exerted 21.5 newtons on the ball to get it to that upward speed. Ooh.